All right, so previously we got VS Code here set up so that we can run Python. We installed Python on our computers, our laptops, and we ran our first script, right? So we created this hello world script. Some of us ran into trouble even doing this, so we'll review that. We run it. The first time you run it, it takes a minute. Hello world. And you see it printing out. Okay? And then, so I'm going to show you a couple things here. First of all, let's say that there's an error in this. And so print should have a capital P. But let's say there's or a lowercase p. Let's say we give it a capital P. First thing, if I run that, sometimes it saves it. For somebody, it wasn't saving it. So make sure you save. When you see this little dot right there next to the name, that means the file's unsaved. Okay? Additionally, something that you can do is in your, let's see, I should look ahead here. In your preferences, or you can do right here in the file menu, we have an autosave option, and I turned it on. So now, when I make a change, you can see that dot doesn't appear; it automatically saves it. It's up to you if you want to leave that. Now it's not saving it automatically; I have to save it. So I like having autosave, but it can get frustrating if you make mistakes and you lose your work. Okay? So anyway, coming back down to here, let's say we put a capital P on this. Okay? And you can see give me a little yellow squiggly under it because it's not defined. So it's giving me some hints that there's something wrong here. But let's say I ignore those hints and I run it. Then I get a note down here. It says trace back most recent call last file, this file here. So if we click on this link here, let's see. Oh, you know what? So it kind of breaks the link because we have the space in the OneDrive thing here. But otherwise, it would like actually open up in the file for us. But it tells us it's in this hello world.py file. And it's on line 1. So if we go to line 1 here, we could say that it's saying something wrong with this word print. It says name error, print is not defined. Did you mean print with the lowercase p? And so we can make that change and it'll work for us. Okay? And so that's the basics of getting set up here. Some other things. Python is not just for executing these files. It's a coding interpreter, and so we can interact with it directly without passing in the file. And so first, let's just see what version of Python we're using. Okay, so there's an issue with my particular computer that I haven't seen on these other ones. Sometimes you might need to set an alias for Python so you can run it. So I'm doing that right now. Okay, and so I think I have to do this every time I reboot my computer. There's probably another way to do it, but I don't have admin permissions on here. So Python, and then we'll say version, and so it tells us the version right there. If we just type Python, it brings up this prompt here, and this is called the Python REPL, and I can execute code directly here. Print hello, right? Or we can do 4 plus 5, right? 4 times 5. Okay? Here's an interesting one. What if we do 4 times 5? Okay, so let's look at this. So if I say type and I pass the number 4, this is what is called an integer or a number. Okay? I can also have numbers with decimals, and those are called floats, and I can also have text. Okay, and that's a string. Okay, so we have these 3 different types of numbers, or types of data that we're looking at, and they all behave a little bit differently, and we treat them a little bit differently, and we use them for different things. So if I want to have text, I use those quotes, and we call that a string. If I have a number, I just use a number, and sometimes we have numbers that are integers or whole numbers, and sometimes we have numbers that are decimals or floats. Okay? Generally, using integers is quicker, and there's some weird bugs that can pop up if you're using floats and you don't really understand how they work. And so remember that inside the computer, when this information is being stored in the memory, it's storing it in binary, which is base 2 instead of base 10. And that can cause some issues with working with floats. But let's come back to the math here. So I can do operation 4 plus 5. Let's try 4 plus 5 in quotations. It doesn't like that, right? So I can't combine the integer and the string like that. It doesn't like it. I can do 4 plus 4.5 though. I can add an integer and a float, even though I couldn't add an integer and a string. And let's see if there's anything else to try. We could divide. 4 divided by 5 is 0.8. I can do what's called integer division, which is how many times 5 goes into 4, which is 0 times. We can also do what's called modulus. So let's say 5 modulus 2. And so this does a division operation and grabs the remainder for us. Okay? And so this is just, again, me using this Python REPL, which you can use, or we can type in here and execute stuff directly. So I'm going to exit out of this REPL. Okay? And now let's come back to writing our scripts. So as we get started here, some things I would like to share with you. First of all, when you write code, each line of code gets executed starting at the top, and it works its way down here. If I want to put a line here that doesn't get executed, I put this pound symbol or hashtag symbol in front, and it creates a comment, which is for users to use as a reference, but it doesn't actually affect the code. Sorry, this is a comment. Okay? And so I'm going to make some notes here in the comment, and if so Python is an interpreted language. What that means is when we run these Python scripts, it's going to read each line of code and it's going to execute it kind of like one at a time. It's calling scripts, or like it's calling like pre-written. I don't want to get myself in trouble here. It's calling basically things that have been written in other languages, but it's basically like interpreting the code like a line by line as you run it. Okay. Alternatively, a language like C is a compiled language, and what happens is when you write C, the code that you created gets converted into assembly, and then gets converted into like a binary that runs on the device that basically is just a bunch of ones and zeros. And so it's a lot faster, but it takes a lot longer to write it that way. And you know, there's some setup involved, and so for any time you want to do something quick or easy, a tool like Python can be really save you some time potentially. But when things start to get complex, or when you need something to happen really, really fast, like if you need to say do a particular operation 100 times, or rather like 1,000,000 times, and maybe there's like a lot of like floating point operations going on or something, then you might want to have something written that runs a little bit closer to the hardware than the Python does. And so, but for a lot of things, Python's really useful. It's designed to work to be kind of like what's called like pseudocode, where like you kind of talk out what you want the code to do. And so Python is supposed to be kind of like bridging that gap there, where you can kind of like, you know, one of the goals that some people have is to create like a natural language programming language, where you can just like give instructions by talking, or like just writing out instructions to the computer. And you know, a lot of these like AI tools are a big step in that direction. but Python is really, I think, inspired by that as well. And so, as we kind of learn about Python, those are, it's one of the simplest ones to use because of that kind of ethos that they have behind it, as well as this is also one of the top programming languages taught in schools right now, and so that's why we use it as a good kind of starting point. Okay, and so the next thing I'm going to show you is variables. All right, so let's say that we have a variable called x, and we set it equal to 4. Okay, when you see this line of code, what's happening is this equal sign is called the assignment operator. Okay, equal sign is assignment operator. And what it's doing is it's saying, you kind of read this from right to left. It's taking the value of 4 and it's storing it into x. And so now if I print x, what will happen is we'll see the number 4 printed. And now I can run it by pressing this arrow here, or I can just go Python and select my file, hello world. I'll press tab to autocomplete it for me, hello world.py. And you see it print out the number 4. Okay? And so here, I've got a bunch of assignment operators. And so the key is I read this from the top to the bottom. So I say x is equal to 4, then I see x is equal to 5, and then it's equal to 7, and then it's equal to 2. And then when I print x, the value here stored in x is going to be what it was most recent. Okay? So if I run this again, you're going to see we get x equals 2. So we didn't ever see it being 4, 5, or 7. We just saw it at the end when it was equal to 2. Okay? And we can also say x equals x plus 2. So we can add x to itself. And so what this is going to do, x is equal to 4, x is equal to 5, x is equal to 7. So remember, this is going to read from right to left, and it's going to say 2 plus 7, and we're going to assign that to x. So 2 plus 7 is 9, and so now x will be equal to 9. And there you have it, 9 right there. Okay? And so this is a variable, and those variables, we can change them, and we'll see the power of variables later. Okay?